Today we're going to look at how to actually analyze a parallel circuit. Hopefully you've noticed there's a couple differences in the lab with a parallel circuit compared to what you saw in series circuits. So the first thing you might have noticed is that the voltage everywhere stayed the same and the current added up. That's the opposite of a series circuit. In the series circuit, the current stayed the same and the voltages added up. So if we look at our calculated resistances, we calculated resistance by dividing voltage by current, and I come up close to 10 and close to 10 for the other one. But the overall resistance is kind of strange. If we look at that, that's 5.5. So the resistance actually decreased. When we look at a series circuit, we add resistors and the resistance increases. So why did our resistance decrease? Well, if we take a look at a typical parallel circuit, what happens? Current starts to flow out of the power source, and then it has more places to go. So there's less resistance to the flow of the current because there's more places for it to flow through the circuit. So this gives us an interesting way to calculate the overall resistance. Take a look at this column. We calculated 1 divided by R for all of these, and those actually add up. So we can't just add the resistances to get the overall resistance. We have to use a little different rule, which is called the reciprocal rule. And we'll go over that in a little bit. All right, let's move on to this worksheet. So here we go. In the circuit below, the voltage drop is 6 volts across each of the 2 ohm resistors. So we want to find the current. Well, the current, I, is going to be V divided by R. So we said our voltage drop was 6 volts. This one has a resistance of 2 ohms. So the current is going to be 6 divided by 2, which is 3. This one's current is going to be the same. It's a 2 ohm resistor as well. So this will have a current of 3 amps. So we get a total of 3 amps. So if there's 3 amps flowing through this branch and 3 amps flowing through this branch, how much current had to come from the battery? 6 amps. 3 plus 3. All right. This diagram over here just shows us kind of a representation of how all of this current flows through the circuit. So we know that 6 is coming out. All right. 3 goes this way. 3 goes up to the other resistor. 3 comes back out of the resistor. 3 comes out of there. 3 goes through this branch, and we get a total of 6 again. Our next question is pretty close to the first one, right? Except this time we have 3 resistors in parallel. So let's find the equivalent resistance of this circuit. Well, again, we have a 6-volt power source right there. All right? So each resistor has a 6-volt voltage drop. Okay, so if the voltage drop is 6 volts, that means this one is going to have 3 amps. 6 divided by 2. This is going to have 3 amps. 6 divided by 2. And then this one is going to have 6 divided by 1. This is going to be 6 amps. So what's our total current? Our total current is the sum of the 3 branches. So if we look, we have 6 plus 3 plus 3. That gives us a total current of 12 amps. All right, we can find the resistance using Ohm's law. V equals IR, or R equals V divided by I. So I have 6 volts divided by 12. That gives me a resistance of 0.5. So let's actually calculate it using the reciprocal rule. So here's the reciprocal rule. If you remember the last column of our lab, the reciprocals of the resistances all added up. So let's find the equivalent resistance of this circuit. So here we go. So 1 over R is going to equal 1 over R1. Well, R1 was 2 ohms. Plus 1 over R2. Well, that one was 2 ohms. Plus 1 over R1. Well, that one was 1. Well, a half plus 1, this equals 2. Well, this is not our equivalent resistance. This is 1 divided by our equivalent resistance. So 1 over R equals 2. So what that means is R is equal to 1 over 2. We just flip it, which is 0.5. So that matches what we calculated up there. So let's look at solving an example problem. First of all, let's look at our rules for parallel circuits. So to find the total resistance, we add resistors using the reciprocal rule. In a parallel circuit, currents add up. In a parallel circuit, voltages stay the same. So this is the same chart that we used for series circuits. There's just a couple differences. In series circuits, the resistance added up. In parallel, we have to add using the reciprocal rule. In series circuits, current stayed the same, but in parallel, current adds up. And lastly, in the series circuits, voltages add up, and in parallel, voltages stay the same. So, reciprocal rule, add, and the same. And the power adds as well. That's just like series. So here we have an example. So we have a 20 ohm resistor and a 5 ohm. So we have 20 and 5. We have 6 volts, so we know that it's 6 volts everywhere. And so let's solve what we can. So our current for R1 is going to be 6 volts divided by 20, which is 0.3. Our current in this one is going to be 6 divided by 5. That's 1.2. And then our currents add up. 1.5. Now our overall resistance should be less. So let's check it. So 6 divided by 1.5 is 4. Okay, now let's check our resistance using the reciprocal rule. So we know that 1 over R is going to equal 1 over 20 plus 1 over 5. Now there's a lot of ways we can solve this. If we just want to add these fractions, we could do this all in our calculator. But if we want to just add the fractions, we could do that. So the lowest common denominator is 20. So 1 over R equals 1 over 20 plus 4 over 20. So 1 over R is 4 plus 1, 5 over 20. So that tells me R is 20 divided by 5, which indeed is 4. Power is calculated the same way. So 6 times 3, 6 times 1.2, and that should add up to 6 times 1.5.